All right. Hello, everybody. Thank you for being here. So as Vanessa said, my name is Judith Lacoste. I'm the founder of a small business called Mia C'est la vie. And you're probably wondering why a small business owner is standing in front of you today. So I'm just going to try to answer that very briefly. So before I started a business, I was in an academic lab and I was in charge of microscopy equipment. And way back then, I was called the microscopy bitch because if you would do something to a microscope, you'd be in danger. Way before that, I was also called pathetically stubborn, and that also is a quality that is compatible with the fact that I've been involved with metadata handling with microscopy stuff. So I noticed before I started my business was that a lot of expensive microscopy equipment were unused, abused, or misused, and that really bothered me. So when I started a business, I wanted to, my vision was that in order to get robust answer to scientific question, we needed to have microscopy that was artifact-free, reproducible, and quantitative. Now, the other reality when you run a small business is that you need to have coverage, liability coverage for professional insurance, right? And this is incredibly expensive. So way back then, it was clear that if I ever had to do a claim to the insurance company, I would probably go bankruptcy. So many, many years ago, I was acutely aware of how important it was to document every process, every activity that I was doing, either for quality control measurement or any kind of data processing and analysis project. So I was gathering a lot of information, but I didn't know about fair science back then, but it was really back then mind-boggling me. How can I make sure that this data can be shared and be accessible and reusable within my own business operation? I also want to say that I was involved, I was one of the co-author on the microscopy reproducibility project from the Center of Open Science. And the conclusion from this project was that we were not sharing enough information. We were not sharing enough information about experimental design, microscopy hardware, and data processing and analysis. And this was an important factor that contributed to the reproducibility problems that we have in microscopy. So more recently, I embarked in a journey where we wanted to capture more metadata. And as you know, capturing metadata can be painful, time-consuming, mind-boggling, all the negative qualification that you can think of, you can apply it to this. So what we want to do, me and my several colleagues around the world, is come up with a way to automate the process of achieving open, reproducible, and fair science. And in order to achieve that, we need to come up with machine-readable and human-readable processes, and that also demands agreeing on a whole bunch of metadata, and that's why I'm involved in this process. So, okay. So this is why I'm standing in front of you today for this session entitled Roadmap to Microscopy Data and Metadata Harmonization. And we're going to talk about challenges and opportunity. The first speaker we're going to have is Katrina Astramio de Castilla, chair of the QCDM work group at BINA, and she's going to give us an update on this work group. And then we're going to have the opportunity to hear from two microscopy builders, because that's what the BINA meeting focused on this year. So we're going to have Mark Sushida and Dane Maxfields from that. And we're going to conclude this session with Josh Moore, who's going to give us a lot more information about the underlying structures that we need to consider when talking about metadata. At the end of the session, all these people will gather into a panel, and we will have two more persons joining the panelists. That's Roland and Anne Plant from the from the NIST Institute. So thank you, Katrina.
Hello. Okay. Hi. I'm going to give you, is there a timer somewhere that I can see? Okay, 2:06. Okay. So I'm going to give you an introduction about what quality control data management what the quality control data management working group is, what it has done. I am the spokesperson of this group, but there is many people in the group. But before we go into who is in the group, I just want to remind you of why we're here. So as Judith has told you already, sorry, I need a pointer. Yeah. So images, we are dealing with images. They, everybody knows about it, but, I just want to remind you that there are special characteristics that makes particularly important to have quality assessment, have metadata to document all the aspects of what we're doing. And we need strong management and sharing infrastructure to make sure that all of this fits together in both machine readable and human readable forms. So the metadata is everything that we need to document, from sample preparation to hardware to quality control settings and quality control to analysis. A lot of it is already being captured in notebooks in other disparate ways, but often is lost and not accessible after, maybe even a week after we have done the experiments if we didn't do it properly. Definitely not a few months later, and definitely not if somebody has left the lab. So we need something to make it machine readable and in sync with the data, and we need data management. So this is the elephant in the room. I really like this, and I'm going to continue using it. I stole it from Eric yesterday, so this is going to be my theme going forward. So we are a group that really deals with the elephant in the room so that we can get science. We all want to do science, but there are things that needs to be done that somebody has to do, and somebody has to keep nagging about, and these are who we are. And so, so we need quantitative assessment and calibration of the microscope. We need the rigorous record keeping, and we make sure that everything is connected together. So we do a lot of different activities. Oh, it's only 2 minutes. That's good. So we do a lot of different activities. And the other important thing is, that it's all in partnership. So yes, we are a group in North America, but there is a whole other world out there. So we're working with everybody else across the world. So it's not just North America, although North America, it's already big, and it's great that we are a trilingual, trinational community. So these are few of the people we're working with, but many more. And so we are working with Quareb to generate community quality control and microscopy metadata standards and annotation tools. We work with a lot of other global efforts to make sure that we can all work together to make sure that scientists are empowered to access usable tools to perform research data management and sharing. And then we do a lot of education and outreach activity. So one of the things that we're really proud of, Judith and I, with an amazing help from, obviously, and essential help from Vanessa and Nikki, we launched last year the AIM user group, which is for automated image data management and metadata annotation and management. And this is a user group, so anybody can join. It's open to all career levels. Please join us and come, everybody. Any question is open. So, it's really to try to make sure that nobody is scared about all what we're talking about. We're all trying to learn it together. Next meeting is going to be October 4th, and the goal for this year is going to be harmonizing the use of REMBI metadata collection templates with as many people as are willing to participate with us. We launched this idea at ELMI in June this year, and already these organizations are starting to collaborate together. And as we are actually going to be represented in the funding guide and German bioimaging meetings in Japan to work some more on this. So please join us. Then we do pop-up exchange of experience. We have been doing one in connection with Beth at various places, and there is one this week, so please join us at the end of the week. And then So there are all sorts of different activities, and so I really don't have time to spend too much time, but please go to our website and take a look at the activities and the events. So we are collaborating with ABRF Core. So the core, this is the Committee on Core Rigor and Reproducibility. We're collaborating with Global Bioimaging. We are part of the Data Management Working Group. We have been working with RRID and the RDA and Core Marketplace to develop persistent identifier strategies for instruments, to make instrument and core facility fair. We have been involved in a multi-pronged advocacy effort with several different people to make sure that what we need to get this stuff done is actually provided by funders, institutions, and research scientists. And then we have the program on the methodology suitcase. So the methodology suitcase, I think I'm done with my time. No, I started at 6. No, I'm okay. Okay, so I'm obsessed about the timing because I promised Judy that I will be on time this time. So, the methodology suitcase, please, I don't have really much time to tell you about, but this is an important program that was inspired by the French RTMFM program to develop basically a case that with quality control instrumentation that can be shipped around, and we can share both the instruments, so the tools, but also the protocols that are developed together with Quareb, and people can start coming on board and start testing them in their own lab and put their, and start actually doing the quality control with standardized protocols. So the pilot phase has been completed. People in this subgroup of the Quality Control Data Management Working Group are working to prepare a progress report with lesson learned and recommendation for the next steps. And please join us. And if you're interested in testing it, if you're interested in telling us about any idea that you have, please join us. Okay, so then there is various different outreach activity that we do. This is a few of the things we are involved in, but I really want to make sure that I tell you a little bit more about what we're going to do today. So there is going to be these 3 great speakers, Mark, Dane, and Josh. And I was tasked with the idea of introducing why are we even here. So the idea is that we're concentrating in this session on one aspect, particularly of metadata, which is the hardware, the instrument microscopy metadata, which comprises the hardware, the settings, and the quality control. So we obviously are all inspired and take a lot of our work from the open microscopy environment community, which has been developing various aspects, which is really important for us now is data model and the readers and the file formats. And so this has been incredibly important for starting to unify the field. And without all of this work, we would not even be able to be here. But there are we need to move forward from that as well. And so there is still a big issue with 160 different file formats, and that there is, even though there is a common model and a common reader, there is still a big variation of microscopy metadata. So we really need to harmonize that. So we are aware that a lot of this harmonization really has to do with the manufacturer of instruments and the people that drive the instruments, so the software that drives the instruments, so that all this information gets harmonized and transmitted in an harmonized manner. So this is the reason why we want to harmonize metadata, and the goals are partnership. That's why we're here today. We talk with people that produce microscopes and software for microscopes, so that we can actually agree on a shared set of specification. We have shared set of metadata framework. So a metadata framework that everybody agrees on, so that all these metadata can be written in a machine readable manner that fits in the next generation file formats, and everybody can read it and write it and without wasting time redoing the bioformats from scratch. And then we want to, obviously, this is all the goal, is to facilitate metadata transfer between the instrument and the image files and automate all of this process. So we are working essentially on the instrument part of the OMI model. And by the way, if you didn't know about it, MBOQ is for the NB Quarep microscopy metadata specifications, which were published in 2021 on Nature Methods. And so a lot of these ideas are described in Zenodo. Oh, yeah. And the really important thing is that we really need infrastructure and metadata to make good scientific advancements. So
Thank you very much, Katrina. Sorry to put you so much pressure about the timing. All right, so our next speaker is going to be Mark Suchida. He's from here. He's a local person, University of Wisconsin in Madison. He's the micromanager core developer, a great tool, and his title, the title of his presentation is Image Metadata from the Hardware Perspective. Thank you very much, Mark.
Thank you, Judith, and thank you, Katerina, for giving me the opportunity to talk here. So as Judith introduced me, I've been working on the open source software micromanager for a little over a decade. And so I wanted to talk about some of the issues and challenges we face when we try to improve how we produce metadata from the perspective of acquisition software that's controlling hardware. And so just to place us in the grand scheme of things, like if you think about the flow of information in our daily lives as imaging scientists, we have image acquisition where a lot of data arises, and then you go and do analysis, and then when you're ready, you publish your data and analysis. And of course, you want to compare your data with other people's data that has been produced, and also these days you might want to be doing smart or data-driven microscopy. So you want your analysis to feed back to your acquisition at different timescales, and in some cases, that will involve a loop. And so all of these arrows contain pixels, but they also contain metadata. And I slightly misled by starting at image acquisition and saying as if that's the start, but really the sample prep and identity is the start. And that kind of happens outside of what I do, the acquisition software. And maybe the place where you enter that manually is in the acquisition software, but conceptually it's a separate branch. And all these arrows say metadata. So wouldn't it be nice if we had a common standard metadata schema, just as Judith and Katerina have just introduced? And yes, I think despite how I phrased this slide, I think the basic answer is yes. And the efforts that have been made by OME and Quarep to progressively standardize the things that are common to different types of experiments, different hardware is all valuable, and we need more of that, if anything. And yet, I think there's also a few things that we need to think about in addition to that, at least from an open source ecosystem perspective. I think there's space for one more component in the ecosystem, or at least that's the argument I'm going to try to make. So the place I want to start from is that metadata plays more than one role. And so this morning, Virginie emphasized the importance of standardization for analysis and interpretation and sharing and reusing of data. But many of us who work with microscopes actually spend 90% of our time figuring out how to do those experiments. And at that phase, we do want to capture everything in as raw a format as possible so that you can dig into the internal workings of your microscope, perhaps, or the behavior of your devices that may or may not be what you expect. And, or maybe you're even developing a new kind of microscope. And once you figure those things out, you still want to do careful quality control of how your acquisition environment is working. And so I think a lot of us spend a lot of our time in this phase, which Eric Bitzik yesterday called fumbling around and putting in the hours, which I thought was a really nice way to characterize our lives, right? So I think we want metadata to serve both of these aspects. And it would be also nice if we didn't have to have different types of ways to store metadata for these different phases, and we had a more gradual and seamless transition. And in addition, I think both of these aspects are critical for reproducible research, because troubleshooting doesn't end when you publish. Troubleshooting might happen after you publish, in productive ways, hopefully. I guess if scientific equipment, microscopy devices were all standardized and the processes you do in your experiments were all standardized, maybe there would be a little bit less tension between standardization and transparency. But, well, first of all, we live in this world, not that ideal world. And also, we're doing new things, right? So we're always going to have things that are not completely standardized. So how do we deal with this dilemma practically, and how do we make that a sustainable process? And I think I'm certainly not the only person thinking about this, but I wanted to point out some concrete-ish examples about things that I have encountered while working on acquisition software. And so this talk is going to be more about identifying and highlighting some challenges than actually coming up with a concrete solution. But hopefully, if it urges you to look into aspects that maybe people who are not microscope builders or metadata experts have maybe not looked into, that would be a great. So the first one is that a lot of hardware parameters actually are two parameters. They can have set points and measurements. And so the example I used here is of the focus drive on a microscope, on a motorized microscope. And the computer is going to command the microscope to go to precise ideal locations. But of course, hardware has some error. And depending on the hardware you have, it might be able to measure the position it actually arrived at higher precision than the actuator that actually does the movement. So I think ideally we just store both of these. So I guess that's something that the container of metadata can account for. But in our actual development of acquisition software, we ran into all sorts of issues, like the fact that some stages don't provide a measurement, which is fine, but some stages don't exactly tell you, at least not in a computer determinable way. Their specs might say, but the computer might not be able to determine if the readout they're getting that's coming from the device is actually a measurement, or if it's just echoing back the command you sent. And there are also other challenges when you start talking about doing multidimensional acquisitions, like Z-stacks, multi-channel, et cetera, that sometimes you might run in a hardware triggered mode that won't allow you to have these readouts, or maybe they're slow. So those are some things that we run into. I'm going to speed up a little bit. And a similar problem occurs with raw measurements and calibrated measurements. In some point in your process, you might want to do power calibration, for example, for a laser. And that's a derived parameter often if your measurement is at the source of the laser and you're actually wanting to record the power at the specimen. And the portable power meter box is super relevant to this. But in terms of the acquisition software, is this even the job of the acquisition software, or should it be something that is more flexibly coupled to acquisition so that the user can specify and verify exactly how the data is flowing? I'm going to skip this one. And then time is a big issue. Time, I think most people, unless they've looked into this specifically, would think that you can just record timestamps and there's only one way to do that. But it turns out that microscopes have dozens of CPUs because each peripheral device of the microscope is its own computer, and communication between the host computer and all those separate devices always incurs some kind of delay. So for example, if you're running a camera and taking a series of images, typically the camera will time those images to be equally spaced using some kind of internal quartz oscillator. But maybe you do a fast burst of frames, and then 5 minutes later, because you're doing a time lapse, you're going to do another fast burst. That 5 minutes is typically timed by the computer, and you have timing jitter. And depending on whether you use the right clock within the computer, you might even have effects of adjustment of the computer clock. So those things need to be taken into account. In Micromanager specifically, we do this fairly poorly, unfortunately. There are ways to synchronize this with hardware, and those are important if you're doing high-speed experiments. But maybe if you're only doing a time lapse, that's not worth it. But then if we don't know the distinction between those time measurements, we may end up with metadata that has time, but we don't know exactly how much you can exert out of that time data because you don't know the way it was recorded. So diversity of devices, this is kind of an obvious point, so I'm going to speed up a little bit. The fact that we have multiple sources of input. So I already highlighted the fact that sample prep and acquisition and all those things have to come together. And also those things happen at different times and sometimes by different people. And so maybe acquisition software is not the only thing that should be responsible for this. Maybe there's a software that takes a log of your microscope maintenance and that should be integrated in it. And then I think this is the one I want to most emphasize, which is there's always going to be a chicken and egg problem between standardization and experiments that people actually do. Every time you develop a new microscopy method, every time you develop a new biological experiment, you're going to have something that's not already a field in standardized metadata. And the hope is that in the future that does become a standard with collaboration and gaining experience. But you do have to gain some experience with those experiments, and in the meantime, record data. So how do we deal with that? And I think this is something that we need to think about as a problem in itself and develop our software and processes and practices around it. Performance, I don't want to emphasize that much. And so basically the message I want to give to convey is what I just said. So metadata is not a static data structure, at least until a certain point. Once it gets into the repository, maybe it is in some aspects, but at the site of where the metadata is generated, it's really a dynamic process where a lot of things contribute to the input from different people and different software components. And those have to be combined and transformed in non-trivial ways. And I think this is something that we need to treat as a problem in itself and have a solution for as part of our ecosystem, especially in open source software. And the challenge is how to do that in a completely general way, or at least as general a way as possible. And I've been given a message to stop. So yeah, I mean, I think I'm repeating myself a few times, but I think that there might be a space in our ecosystem for an additional software, maybe library that is not overly tightly coupled into acquisition software so that people can reuse it when they write their own custom acquisition software for specialized experiments that will help with collecting and generating and combining and transforming the metadata at different stages. And I would like to thank my coworkers and funding. Thank you.
All right. Thank you very much, Mark.
The microphone's very feedbacky. Yes.
Yeah, okay.
Just
I just wanted to say thank you to Mark. And our next speaker is going to be Dave Maxfields. And Dane is going to present over Zoom. And the title of his talk is The Devil in the Metadata. I think we all agree on this idea. So let us know when we're ready.
I should be set. Can you guys hear me through the
We
microphone?
can hear you loud and clear in the room.
Perfect.
Yes.
That
We
is
will
great. Thank you guys for allowing me the opportunity to speak on this. It's a much different topic than than I stereotypically speak on. But all in all, it's a pleasure to be able to present for BINA. Apologies, I could not be there. I had some issues that popped up late Sunday that prevented me from getting on a flight. As you can see, the title of my talk is The Devil's in the Metadata. I'm going to go through a couple of these slides really quick at the beginning because I want to get to the discussion points, and it's nice to see that Mark and I are very on the same page. And I'm going to be approaching this from the industry perspective very quickly. I work for Bruker. We are a conglomerate of a bunch of different companies, and I am part of the light sheet division. And I will argue with anyone here that I probably produce the most data and metadata out of anyone that's sitting in the room. And particularly one of the challenges that I have as a vendor is taking some of these experiments and having people say, hey, I want to recapitulate this. How do I go about doing that? Well, metadata is extremely key. So use this to show some pretty movies at the same time, but the idea with this is metadata is the data behind the data. So in particular, we write JSON formats, which will have pretty much everything that we can measure inside the microscope that is put into a file so that I can look at that at any point in time and see what microscope, what software build, what objective, what detector, what particular type of excitation, and I've got a little arrow there pointing to sample prep, even though that's not something that's encoded in the metadata. But as Mark said, mentioned before, I feel that there's kind of 4 essential elements for data reproducibility. And the first one happens before we even get on the microscope. So sample preparation and sample preparation details. This is stereotypically something that needs to be documented by the user in a lab notebook or some other way so that we can stereotactically prep the sample in the same way to get reproducible experiments. The second is hardware specifications. We got a whole slide on this after the fact, so I won't spend any time on that. Third, and it's always great to hear 2 other people talking about this, hardware calibrations, point spread functions, power density measurements, things like this, so we know how our microscope's performing, because without a microscope that's performing properly, the metadata might be essentially useless. And last but not least, all your image analysis settings, things that we are doing to the data after the fact to extract the parameters that we actually care about that are relevant for our publications or our analysis at the time. Specifically, I'm going to be focusing a lot on 2 and 3, the hardware specifications and the hardware calibrations. I'm going to burn through this slide just so I can sit there and go through discussions. But ideally, with these new modern automated microscopes, we're typically getting about 6 categories of metadata, things from the microscope manufacturer, software builds, hardware specifications, metadata about the excitation and emission path, as well as the detector that's used to collect that data. Once we're doing more than one Z-series or time lapse, we're getting experimental parameters such as step size, volume, imaging cycle, and timing, and then the metadata around advanced components, whether that's a spinning disk, a point scanner, or a light sheet like I represent. What I really want to spend some time on is kind of these next 2 slides, which are the big challenges that I see from an industrial perspective. And the first challenge is really proprietary formats of data and metadata that are coming out. Every different manufacturer writes their data and their metadata differently. And a lot of times it requires that manufacturer's specific software in order to extract all the meaningful components. And one of the challenges that we have is some of this metadata can be quote unquote lost when we convert this to an open source program. The basic things get brought over, like pixel size and image and grayscale values, but some of the other important things for recapitulating an experiment might not be transmitted into that transition. The second is standardizing metadata formats. I thought about sticking a poll on here, whether it's an XML or a JSON. I've seen people go both ways. But really kind of what metadata should be written. I'm in the camp that more is better, but more can also cause you to swim in a sea of data and you might not know what the relevant parameters are. Again, hearing this multiple times is nice to hear. That the metadata needs to be written in a format that is both machine and human readable. So the fact that we can import this into a machine, and I'm going to touch on that later when we get to smart microscopy. One big issue that I've seen with metadata coming off of some of these advanced microscopes is the metadata itself can actually require advanced knowledge of the microscope or the architecture in the microscope. I'll use an example from my particular systems of the ability to do a bidirectional Z-stack, so going from A to B, B to A, versus a reset Z-stack where I go A to B, A to B, A to B. And if you look at the metadata for my systems coming, or the metadata that's come off of each one of those experiments, you would have to know exactly what parameter to look for inside that metadata to know whether it was a bidirectional or a unidirectional stack. And that right there presents a big challenge for, again, recapitulating some experiments. The third challenge is recording metadata from quote unquote other sources. This could be external devices that don't actually talk to the computer. This could be your users delivering drugs. How do we log that in a way that is recordable so that we know when that happened in the experiment or what was used downstream? The fourth is timing is everything. Mark touched on this beautifully. What determines the timing of the experiments? I know a lot of my stuff is driven by an FPGA and the camera timing, but that doesn't mean that when I set a quote unquote 5-minute interval, that it's going to be a 5-minute interval between the different stacks. And there's a lot of external factors that can play into that, such as hardware movement times, et cetera, et cetera. And how do we also write data fast enough? When we start getting into calcium imaging, voltage imaging type experiments where we're doing hundreds or thousands of frames a second, are we able to actually record that data fast enough to be able to go back to that experiment and say, hey, we could do this over again? And last but not least, knowing your hardware. Power density, power density, power density. I'm going to harp on that. I harp on it for everyone that I talk to. If you're doing live cell imaging experiments, knowing what your power density at the sample is 100% essential to being able to recapitulate these experiments. Also doing things like hardware calibrations will, in doing that routinely, to make sure that the data coming off the microscope is something that we know is standardized so that we could be able to do those experiments again. Some challenges that I see as far as metadata. The biggest one that's kind of, I wouldn't say concerning, but is something that I think about a lot is on-the-fly processing. Things like denoising, deskewing, image fusion, and stitching. These are all possible with the newer detectors and things out there. And does that data or metadata actually get encoded, or do we end up losing it during that process? How do we go from those quote unquote raw images, and what is a raw image anymore? That for me is something that definitely needs further discussion and clarification. Smart microscopes. This is something that we're exploring from commercial entities, as well as, we've seen papers out there from like Kate McDowell, for example, using the autopilot to adjust parameters on the fly. I also have people that are using machine learning to adjust the microscope through Python scripts to be able to acquire Z-series faster, to increase the size of your Z-series to accommodate growing organisms. These all present challenges for metadata in replicating experiments unless these modes and models and parameters are extremely well defined so that we can go back and do that over again. The third is custom microscopes. How do we know what to measure when we are in the process of making something different? Do we focus on collecting everything and swim in a sea of metadata, or what do we, how do we figure out what is reasonable and necessary for reproducibility? And the last, and this is a challenge that I've seen again from the industry side, is starting to combine these modalities: X-ray tomography and light sheet, single molecule localization, and EM, being able to correlate these particular and very different modalities and talk to the data and metadata in ways that I know exactly where to go on my EM slide or on my single molecule slide in order to take an EM image. How do I load that data in from two different data sets that have been captured on different images and explore both of those simultaneously? Those are, challenges that either require a dedicated grad student or postdoc, or a standardization of the metadata so that we can do both of those simultaneously. So take-home messages here. I hope I'm cutting this short because I'd rather be short than long. The metadata is more than what the microscope provides. There is definitely a user component to this. And I'll also argue that the training on the microscope is essential for providing the necessary metadata. The more that we use and understand our systems, the more that we understand what parameters are actually important for being able to go through and redo these experiments. The second take-home message is writing more metadata. If you've got a fever and the only prescription is more metadata, let's write everything, or at least give the option to write everything so that anything that's measurable by the computer, so that we have enough to go back and redo some of these experiments. And I couldn't think of a third thing to stick on here, so I'll just write measure your power density and record that on a monthly basis. And with that, I'd like to thank everyone and appreciate the opportunity to present here. Cheers.
Thank you, Dane. Lots of applause in the room. Josh, if you want to start sharing your screens.
I have to keep clapping first, so All right, so that was great.
Hold on, Josh, 2 seconds. I'm just gonna say thank you to Dane again. And Josh, I'm gonna take this opportunity to introduce you live in this audience today. So Josh is a research software engineer. He's been heavily involved in the OME, the Open Microscopy environment. He's a part member of German Bioimaging, as well as the German NFDI for Bioimage. And the title of his talk is Scalable Strategies for a Next Generation of Fair Bioimaging. Thank you, Josh.
Thanks, Judith. Hi, everyone. Very sorry I can't be there. Part of that's just, it's nicer to talk to all of you in person, but after hearing the last two talks, I think the beer conversations would have been very much worth it. Hopefully we can make that happen in the future. I guess I don't have to introduce myself. A different title for this talk would also be, following on from what Mark said, imaging data from the software perspective. So we've heard hardware, we've heard industry, and I'll try to represent what we've learned over the years from the OME perspective, and maybe start off the conversation of how we can fix all these things that everyone's talking about. What I'm saying more and more when I give these presentations is that from our perspective, most of the world's imaging data doesn't yet have a way to be shared. I mean, we've just heard lots of different categories of metadata that aren't recorded anywhere. The same is true in our repositories. Anyone who's trying to do AI and collect training sets, we still have quite a ways to go. And I say that from the perspective of someone who does nothing else, right? So, I mean, these guys, they're talking about metadata, but they do other great things. all I try to do is build the infrastructure for sharing these things, and we're still not done yet, right? Going back to Katerina's metaphor of the pipes and the beautiful fountain that's sharing knowledge, I build pipes, right? So what is it that we've learned in trying to build these pipes, and maybe how can we do it better in the future? I mean, the big one, of course, is going to be bioformats. And I'll come back to this slide. Fundamentally, bioformats, which has been around for quite a while now, tries to take all the file formats that have been talked about and capture as much metadata as possible into a common model, right? And I'll talk about that model as well. But the important take home is we are losing things. We can't transform everything. And so what do we go about? How do we fix that situation? Things we have tried in the past to capture more are trying to define a common exchange format like OME TIFF. Many companies can export it, but they will also know that they're not able to write everything down because they're limited to what that central model provides. In Omero, we offer a database, and the users can add all kinds of annotations on top of their data. But then when they go to share it, they need to get all of the same imaging data, the same imaging metadata back out and get it to someone else. And so they're left with that bottleneck. They're blocked. And then with the next generation file format that Katerina mentioned, can we scale to the limit of the cloud and the web? Can we collect all of our data into these large containers? But we're still left with the same problem. Over and over again, we come back to metadata. And so from our perspective, OME's perspective, I would say often it feels that the pipes are getting bigger or the needs are getting bigger. Somehow it's going to be that we're going to need to work together to find a solution. And I think what that solution will be, if the problem is that we're not able to share all of these parts of knowledge that we have either at the hardware level or in the users' minds in their lab notebooks, the solution is really to maximize how much we work on the same solution. And it doesn't have to be the same metadata. I would very much not say we should all write down exactly the same metadata, and we've heard from the others that that's true. But I think we do need to work on how we're writing down the metadata. I think there are many conversations just about what is going to be our strategy. And I want to just kind of kick that off today, and then we see where we go. And for the record, this isn't particularly new. You can go back to the original bioformats paper, which is the most cited paper from OME, 2010 in Journal of Cell Biology, where we kind of laid out the model and also our strategy and why it's so critical to capture as much metadata as possible. But there was a 10 bullet point box explaining how we should deal with these formats, and I think they're pretty much still spot on. It's just we haven't been able to solve the overall problem, and there's a clear tension. So we were asking, can we get the commercial community to share all the metadata that's in their system in some kind of open format? But the quid pro quo was that we need some way for them to do that. We need the libraries and all the things that Mark was talking about. We need to be able to capture those. And so, yeah, I'll show you the advances in working on that. So kind of the history, the trajectory of working on this model is it started with being able to represent 5D imaging. That has evolved over the years. And every time we evolve the model, we update and downgrade everything. So we try not to lose any of the data. But we have realized through the years, so back in 2008, there was a major effort. It took 2 to 3 years of talking to many, many groups to standardize on what is high content screening. It's probably wrong today. The technology has changed. And that's where we really began to realize we can't keep up. The technology changes so quickly. We needed to introduce flexible systems that people could write in the OME XML or write into Omero what they needed to write without coming to us and asking a question. That went on to add support for key value pairs, so much more user-friendly ways of kind of writing things down as you would in a notebook. And then as we built the IDR, adding in support for ontologies and more kind of linking out to the community. The thing is then, though, when users like Katerina and all those working on NBOQ came to us and said, well, we want to extend the OME model. We want to take responsibility for the hardware aspects of the model. The infrastructure wasn't there. It wasn't possible for them to go to say, okay, we're going to now be the responsible party. They actually had to come to OME, and we had to use all of our write all the upgrade scripts. Fundamentally, it was getting to be too expensive for us to upgrade the model like that. What I think we've learned through that process. So that was around 2018. And since then, we've been talking. There have been working groups and all the regular things that, all the bits and pieces that Katerina laid out for everyone. I think this is kind of the titration of the lessons learned, is that if there's an existing spec, so here, blue circle, right? And someone comes along and they want to say something new. So you're building a new microscope, or you want to upgrade things, or the technologies have changed, green box. What you can't do is you can't say, well, I'm going to just take the old stuff and put it in the new stuff, because software doesn't work anymore. So as the person who has to write the software, I don't want to have to rewrite everything I've done each time someone new comes along and needs to write down their metadata. So if our goal is to be able to write down everything that has been talked about, and I've just learned it's power density, right? We need new strategies of doing that. And so there are multiple ones we can choose. So the how are we going to write it down? And I'll list 3. And I think that's one of the big conversations we need to have. First is you can take the existing specification and make it available somewhere. That can be via an API, or we've had conversations with various companies, for example, at the LME meetings, about taking a copy of their metadata. So they will export the metadata to the blue format. That would be a fine strategy. We can separate the 2 types of metadata. This is often called a sidecar file, and just have 2 pieces of metadata, and the blue software reads the blue metadata and the green software reads the green metadata. It would be a possible solution. Or you can take the green metadata and you have to embed it into the blue metadata. That's where we failed. So we would have to, as a community, when we have the existing specifications, we would have to make sure we build them in such a way that people who are coming along can put their extensions into that metadata in a formal, as it's been said many times, machine readable way. And so again, that's where I would really like to see more of us investing. Obviously, it's way more complicated, and that's my kindergarten drawing. What we want to achieve is that when existing software runs into new data, it's able to interpret it to the best extent possible. So let's imagine, so a slightly more complicated drawing. We have the existing blue blocks, we have additional metadata in green, say coming from a company. What bioformat sees today is basically just the blue blocks. Everything else gets lost. We just can't do anything about it. The goal would be that we see that internal state in some form. It won't be perfect, but it will be much, much better. And so even if there's this deluge of metadata that Dane was talking about, we would still be able to work with it, right? We wouldn't be completely at a loss. And so the goal would be, rather than the 6 green blocks, which all include, 6 little blue blocks that get lost, it's the minimal metadata that becomes uninterpretable to existing software. And it's going to be work. There are various ways to do it, and those are the conversations I think we need to have. So in preparing for this session, I got a chance to talk to Mark, and he ran me through some of his challenges. Didn't work out to talk to Dan, but I think you can already see how each of us is saying, well, if we do this, then I'll be able to represent that, and we can work together. So I wrote down his stage position example from a developer point of view in at least 3 ways I can imagine doing it, and that's fine. Any of them will work, but we need to agree on them, right? And those are the type of conversations to run forward. And there are many people that are working on this, and I have some extra slides that I will not be able to get to. Just checking my clock in the background. And everyone's working on it in a slightly different way. So I think at the easiest end of the scale, you start off by just trying to agree on terminology. Are we all using the same term in the same way? Do we agree on what the definition of power density? Getting slightly more complicated, you can talk about the relationship of the various fields in terms to one another. Then you start to have a schema or a model. And what I would really love for us to find is the way to have a framework that we agree on, such that there's something out there in the community that's being done without our paying for it, right? And we can build on top of that. And that means we don't have to build everything from scratch. And what that will get us is the ability to write code and have versions and more structured way forward, which we've done in the past within OME, but it's of course limited. It doesn't encompass the whole community. So how do we take this kind of very orderly way forward and open it up so that everyone's free to write down all of their metadata, but we don't kind of end up with I don't know, pick your metaphor, I'm mixing them now, a swamp or a spaghetti or, whatever you don't like, that's what we want to avoid. So just very briefly, What I've been working with most concretely here over the past year or two is a combination of one, more terminology or schema, schema.org, and I'll show you a framework in just a second. Schema.org was developed a little over 10 years ago by the search giants, Google, Microsoft, Yahoo, Yandex. More have joined. And what it's used for is enriching email and websites such that, again, code, when they're seeing your website or they're reading your email, can find, oh, here's a suggestion for a flight versus, oh, here's a suggestion for an event. So the basics of how we want to talk to one another. And I picked out one particular term here, the product model, that possibly is the basis for what we want to do. But it would be up to us to then evaluate these and say, this is something we can work with or not. For what it's worth, it is complicated to add terms to schema.org. That would be a downside. But if it provides everything we need, perhaps it's a starting point. And there's the project RO-Crate. RO stands for Research Object, which developed in the UK, builds on top of schema.org and takes binary artifacts from anywhere in the research pipeline and adds a very thin layer of metadata on top of them. And I think that sounds quite like something we want to do. And I think it's nice that we can all then look to an existing framework and say, that's what we're going to depend on, as opposed to each of us building his or her own framework, which is what I would really like to avoid. Just very briefly, an example of what that looks like in bioformats. When we read all these green blocks, it looks like what's on the left here. For us, it's uninterpretable. And the hope would be that having this RO-Crate structure or JSON LD structure on the right, we'd be able to take particular terms and provide companies the mechanism to write them down as explicitly as they want to and can, but that in the future, others would be able to interpret that. It becomes a blue box that we can all use quite openly. So this is one possible metadata stack. There are others just very much want to agree on one. That will let us build bigger pipes, right? If we're more people working on fewer types of pipes, the pipes can get bigger. That's a good thing. And an optimistic future would be that bioformats is no longer responsible for translating every format into some minimal subset, but rather that everyone can write things down in such a way that they have the primary data, but they also have the metadata that links out to as many frameworks as that are necessary. I guess there could be a marketplace of schemas out there, and everyone is invited to participate. No one group needs to be in control. Because fundamentally, if we don't have the complete metadata representation, it will be very difficult for us to come to a unified format in the future. Okay, final message, and I'm shutting up. Creating metadata representation. So as a developer, is very, very easy. I can write them down all day long, right? The hard part is really coming together and agreeing on how we're going to write it down in the future. Thanks, everyone. And thanks to funders and everyone who's worked on this over the years. It's been quite a roller coaster.
Lots of applause in the room. I'm going to pin you and Dane and Anne so you can participate in the panel, Josh.
All right, so we're going to have well, first of all, thank you, Josh, and thank you to all the speakers. So I'm going to invite Katrina, Mark, to come down for the panel discussion. I also want to invite Roland Nischke, and I'll give a brief introduction to Roland. He's our colleague from Germany, and Roland is the person who started the organization Quarep Limi. So for those of you who don't know, Quarep Limi stands for Quality Assessment and Reproducibility for images and instrument in light microscopy, something like that, right? They may not be in the right order, but I think I got all the words. So Roland, we're lucky to have Roland here today with us. We also have Anne Plant from the NIST organization, National Institute for Standardization of Technology, or something close to that. So all these people are in front of us today, and you've heard this many times in this session. It's about working together as a community, sharing, getting organized. So this is the perfect moment to express your voice and address our challenges, success, and future work. All right, I'm going to, I think if it's possible, I'll let Anne and then maybe Roland after that perhaps give extra couple of minutes because they haven't had a chance to get the mic. Right? Thank you. Go for it, Anne.
Okay, great. Thanks. And thank you so much for inviting me to be on this panel. You know, I usually get all my information about this organization secondhand. So this is really fun for me to be actually kind of involved. And I'm so sorry I'm not there. It was thank you, United Airlines. At any rate, so a lot of you, well, I heard NIST mentioned a couple of times. I know a lot of you know something about NIST, but I think it's probably good to have a little bit of introduction. So the National Institute of Standards and Technology, we're the National Measurement Laboratory for the United States. We're actually part of the Department of Commerce. And so that gives you an indication of how important our work is for industry and commercial developments in the United States. Well, first of all, we are like many national laboratories around the world. And so, that might be represented here. In fact, I don't know, that all have a responsibility like ours for setting standards or being involved in standards for their national interests. What we do at NIST is we're responsible for reference materials and also for international standards and national standards. A lot of work in AI and cybersecurity. We also do a lot of work in interlaboratory studies. So I'm really excited that you guys are doing this thing with the suitcase. I just think this is, you've done great work that NIST couldn't have done. And, because you have the community in the ears of the community. So it's really great. We do a lot of work with companies. And so, a lot of that translates into our work with ISO and other standards development organizations, and I'm happy to talk more about that. Some of you may have, but one of the things that we do a lot of basic research on measurement technology, and we also do a lot of convening of workshops. Some of you may have participated in Peter Bege's workshop last year on fair containerization, so we've got actually a pretty substantial effort in our information technology laboratory that we work with very closely as the biological imagers. One of the things I'd love to hear more about, and Josh, I loved where you were going in your talk, because I've been associated with this kind of work for about, I don't know, maybe 20 years, and it hasn't really, we keep making the same mistakes, because it's really hard. But now I'm seeing folks, I was just talking the other day with people at NIST who are doing research in the use of large language models to help develop metadata for the CHIPS Act. And this is kind of interesting because they're using the large metadata, these large language models to develop definitions for metadata that people might suppose. And then, there can be a consensus on this. And then somebody else is building on this to develop RAGs, retrieval capabilities for how to better query language models or how to query small language subsets of language models that go into databases. And, so now I can sort of start to see how we might be able to take really federated efforts where everybody might have their own metadata, but they can query everybody else's metadata with a common language model, basically, and common queries. So I'm really excited that this is actually going to happen. It's really fun, and thank you all for letting me be here and participate.
Thank you very much, Anne. So I'm going to give the mic now to Roland if you want to give something more of an introduction.
Yeah, so I will talk a little bit about the reason why we started Quare Blime in 2020 and how quickly it evolved. I think now in a major effort to standardize, I would say, measuring quality, assess quality, and also document quality, and that also brought me together with Katharina and others working on finding a common way how to hand this over to the images. So in the end, I think it's quite important that in Quare Blime we have a very nice collection of around 80 companies working in the microscopy fields. And I think all the major players are in there, as well as the smaller companies. And it's not only the microscope companies, it's also the laser companies or stage producers and so on. That's important because in the end, what we have to agree on is common naming. And a very good example that it can be done is what we are currently near to finishing. We brought together all the major camera manufacturers, including the OEM part of the microscope companies, and we agreed on a common language. And that is, I think, the way we have to do it for all the other parts of the hardware of the microscopes, so that in the end, we have a package where everybody agreed on common naming. And that is, I think, the first step to standardize things, how you can save things. And then the next step is nicely outlined, I think, or the problems by what Josh was telling us. So I really can, ask all the companies come together in a common framework and talk with us, with the academia and the industry together. And this can be a success story. And currently, I favor actually maybe doing it in the framework of ISO, because that was brought up around a year ago. It was a surprise for me. It was brought up, I can tell it here, it's not a secret. It was brought up by Nikon, and it was pushed actually forward by the publication of the papers in Nature Methods. Yeah, I was surprised. So it was recognized in the industry, and it was recognized that it is very, very important that we somehow standardize this. And so I will be in 2 weeks in Boulder at the ISO meeting about the microscopy. And there I hope that I can present a one-pager where we summarize how our tasks have to be within ISO. But it's clear the current format of ISO, that is not enough, because there we have only the 4 big companies mostly, but we need all kind of experts to integrate that. But what I hear also from the industry is ISO is very nice, because if we come up with something in ISO, then it's very easy that in other companies, oh, you have something in ISO, we follow that. So it's like putting up the flag and say, come with us and join forces. So I hope we can do that.
Thank you very much, Ola. Katrina?
No, I just.
Okay, so, well, look, I think one of the things that Josh said in his presentation, and this keeps being repeated over and over, is maximize our effort on shared infrastructure. And now currently in this room, we have microscope builders, we have manufacturers, we have organization like the NIST and Roland representing the ISO, and we have all of us microscopy users. So I think we have the perfect crowd to brainstorm together on how we can move on these challenging topics. So are they? Yes, I see one. I see a couple of hands up already. So I saw Phil.
Hi, Phil Hochberger, Northwestern University. So, Anne, my question for you is, do you at NIST have to deal with technologies that eventually become obsolete in your standardization? Meaning, some things are going on, the measurement of a meter, indefinitely, but there are other technologies that have a finite lifespan. How do you deal with it?
You know, that's such a good question, because the meter that used to be, or in the kilogram that used to be a physical artifact, we don't even use those anymore. It's all based on excellent measurements that have allowed the use now of fundamental constants. So the speed of light is actually the basic determinant of the kilogram and the meter. So so things do change, and this is one of the things that's tricky about standards, is that the worst thing that you can do is lock a field into standards that are not changeable or that are not serviceable. And so, you know, it is possible that a standard works for some short period of time, but it's probably not going to work forever and ever. So it's really important that one, addresses the question, the idea about standards very carefully and understands what the limitations and benefits are. I'm so delighted that you guys are getting involved in ISO, because there are really huge advantages to ISO. There are also huge disadvantages, but I think in this case of manufacturers of microscope systems getting all on board with respect to what they're going to call stuff and what kind of format they're going to provide that instrument invitation and instrument information in is just huge, and ISO is a perfect place for that to happen.
So hi, I'm Alison North, Rockefeller University. Hi guys, fabulous talk, Dane. Thank you, fabulous talk, Josh. I'm going to be a bit rambly here. Sorry, this is something that's been bothering me all day. I have to give a presentation next week to the Rockefeller University Press about what they should include about microscopes when they're, what authors should include when publishing images, and the challenges for us with microscopes. And the elephant in the room that's been bothering me since this morning is that I don't think anyone's really made clear to the users, when we talk about image quantification, what can be quantified and what can't be quantified. So this is a question all the time. They say to me, I want to quantify my images. So quantifying distance, okay. Quantifying shape of organelles, fine. Quantifying intensities, And I think they don't understand this. And my problem is that, there are all these fancy new microscopes with denoising, deconvolution, AI, computational clearing. All these steps are completely non-quantitative. They do not come up with a big red flashing light, which I have asked them to, saying, warning, after this step, your images are no longer quantitative. Nobody knows this. And so everyone's so focusing on making images pretty. And sure, if you make them prettier and deconvolve them, maybe it's clearer to measure distances, but you can no longer measure intensities at all. Depends on the deconvolution. There's an argument with Glenn here right in front of me. So my question is, could we somehow define what we even mean by image quantification? Because I think until we do that, we're just confusing the users all the more. What do people have to say? I'm sorry, that's like a real ramble, as I say.
Yeah, listen, one point is AI makes it even worse, as you say, yeah? But we have to be realistic. Up to now, I think quantification with all the instruments in the market was never, ever a thought of making why you did these instruments. No one was thinking about that. And if you would have talk about medical instrumentation, that's completely different, yeah? Because if you do their mistakes, then you will be suited and you will have real trouble, yeah? In microscopy, no one will hurt you if you do quantification, which is just garbage, yeah? That takes time all the way, yeah? So, but we have to, yeah, somehow it's education also of all of us, what we mean with, as you say, quantification, and we have to be aware. Up to now, it's not really good how we do it.
So there is this person here who's been waiting, and there is somebody.
Yes, just as a reply.
Okay, sorry.
Yes.
Yeah, I guess just briefly, I don't have a great answer for Allison. Where she started with what should the journals do scared me. So I listened to it and got more and more nervous, because I think we have a lot of work to do until we get there, right? And I think maybe there's a conversation to be had to ease them into it, but I would really like for us to do it kind of properly. Going back to what Anne and Roland are saying about ISO, there's a lot of legwork. I had a slide that I left out for time reasons. It might be worth it to look at some other communities. I'm thinking of the geospatial community. So satellite data goes through a set of levels. It starts off at level 0. I think I have it the right way around, which is the raw data, and it has certain parameters. I think that Mark talked about raw data and then it becoming more and more cooked. And in geospatial community, those levels are well defined. And so if you know, the satellites are acquiring things in various different orientations, and then one of the levels, it's either 1 or 2, you bring everything back to a common coordinate system. And then you know you've done that, and you've had to record what you did. So I think we could be very formal about how we, you know, do we give it a name? And once it's been gone through AI, you know, I won't propose a name because it'll be rude, but that will be on the other side of some bar, and then certain things are no longer possible. I think what we don't want to do is prevent people from doing things, you know, so from my point of view, at least, I would want to capture everything you said. So all the complexity, Allison, that you spelled out, and give it all a name so that we can talk about it and agree with one another about what it is, but not try to go further than that, if that's useful.
So I just wanted to address Allison's comment. So and turn it into a question, which also I think goes back to what Dane was saying. You know, well, there is definitely the idea of, you know, what can we measure, but there is also the question of what is advertised as what we can measure, which is one aspect. And then there is how do we make sure that we have the information about what was measured. So what are so I'm actually going to turn a question to Dane and saying, you know, you mentioned, you know, basically what your talk was basically, you know, it was basically like you're teaching to the choir as far as I'm concerned. Everything you said, I agree with.
Yeah.
The question is, what are the challenges for companies that to actually do, you know, work with us to actually achieve some of these goals so that we can capture all the metadata and we can keep it like compatible, like Josh was saying. So what are the actual, if you can share with us, what is that is blocking it so that we can actually move forward and address the challenge?
I think part of it, I would say part of it is, you know, a common data and metadata format, right? So from our end, the OME TIFF doesn't work for the data stuff that we do, and we have to actually move to H5 and some of these hierarchical formats because our data is just too big, and so we don't fit in that block. For doing that, I think we could write our metadata differently so that things could be done, but the JSON file is also one of those things that I think is becoming more and more accepted, and Josh showed some great examples of how that's actually readable. So I think from my perspective, a challenge, if there was something that you could say, hey, fit this into these particular blocks, call, you know, your stage parameters this, your camera parameters that, that's easy enough for us to implement, but that does not seem like there is a unification out there for us to do that.
All right, thank you very much. Yes, please go.
I think just kind of continuing on a similar thread of sharing or recording metadata. I wanted to know if anyone on the panel had either like ideas on how to actually report and share our metadata when we are publishing, and what that might look like. Like I really love the idea of like a JSON file that has everything written up in a very organized, clear manner. Not everyone does that. But when we are working with various company file formats, how do we imagine recording and sharing that metadata in a publication, whether it's in the methods section, or are we like, should we be writing things out and hosting them on GitHub or utilizing some sort of server so that way people can access all the metadata they actually need to recapitulate the experiments we're doing?
So there is, there is no, immediate solution. We're working on various solutions to that. Well, first of all, one of the aspects is clearly then, how so you're saying putting it all in a JSON. The question is, that's why this whole idea of a shared format, so that JSON or whatever it is, everybody can have readers and writers for it. That's one aspect. How do you get it in there? because that is another big aspect. Is so there are you know, we are working specifically with Homero to upload images so that they have the information in it, so that then when it would download the data set, it has all the information and it can be shared in a repository. We're working to produce templates that can be, for example, implemented in Excel, so that the aspects that the user has to enter, which is the sample preparation and experimental conditions, can be entered in a way that is not immediately machine readable, but it can be more easily made into machine readable. So for example, in a JSON, can be transformed into a JSON file. People are developing tools to collecting the microscopy metadata that is not already in the header. So there are various solutions. You know, the more, so for example, if you are interested in exploring some of these solutions that are being developed and, you know, questions and answers, you, for example, can join our AIM user group, in which we are really discussing about this and looking at, you know, challenges that people have and, you know, starting to develop solutions together. But for example, for experimental metadata, we're looking toward RAMB compatible templates so that people can start entering information there. Okay.
Yeah, Josh has a reply too. Go ahead, Josh.
Find if Roland wants to go first. Usually in these things, it's my job to be the pessimistic one. So having, you know, Katerina, I agree with everything Katerina said. So, you know, big thumbs up. So I'll try to be the optimistic one, which would be the long-term vision that we would want to achieve when having, you know, software that can do all this, et cetera, and everyone working together would be, you don't have to care. So I don't think you said your name, but I think, you know, you should be able to do everything you listed and it should just work. And that means you should be able to take things off the scope, enrich them with other metadata, put them on GitHub if you want, upload them to the bioimage archive if you want, put them in Homero if you want, and none of that metadata should get lost, right? And so tell us what it is you want to do and push, and probably some more people work on getting funding, you know, and we go that direction. It's achievable. And for what it's worth, if I have my optimistic hat on, you know, I have more hope at the moment than I ever have before. I think still, you know, trending up. So until something stops us, then let's do it.
Excellent.
So
yeah.
I like to comment on that as well. So
please,
Josh, actually, usually I'm the optimistic guy, and but now I would be currently. I think the situation is that there is really heavy amounts of metadata in the original file format. As soon as you go away from that, you lose most of it. And the worst thing is also that there is metadata in there where I think even within the company, there is not one person knowing what metadata is in there, because it's different sections of developers who say, we have to save that. So this lands in the metadata. What is important for you maybe later, or for a scientist, you have no idea of, because, yeah, so we have to find a way that more or less, as we say, we agree on a common language, and that may contain 80% of what is useful for us. And then there is maybe 20 or even more % available, which is only important for the company, and no one has any interest in that. And it's maybe also not useful for you to know that it's there. But still, we have to find a way that this is not lost as soon as you go into a common storage format or something like that. And that's the major task.
Excellent. Yes, Anne.
So I have kind of two questions, comments about that. One, I'd like to ask Dane what kind of pushback from a company's point of view does one get for participating in ISO? And is that a challenge to bring more company representation to ISO in order to get that buy-in. And then the second question I have, and this reflects perhaps my optimism and ignorance, which is, could we not base a lot of this challenge on the use of databases? Like if we just dumped a whole bunch of metadata into databases and had clever ways of searching that metadata and pulling out the metadata terms that we wanted with the definitions that we agreed to.
I'll jump on the first part. So from a company perspective, I might be a rarity here, but we when we were creating the data file formats, we actually had open discussions about what to include in this. And at the end of the day, since there wasn't anything standardized for us to put out there, the consensus was anything that we can measure or write, we stick into a JSON file and we'll let people dig through that, because with the more information, the better. I'd rather give you guys more parameters and a super long text file that you can search through than saying, oh, well, you didn't record this particular parameter. So if there's, like I said, if there is kind of set things that you would say, these are the relevant parameters for the particular microscope or the particular measurements that we want, I think my developers would happily jump on that. I can't speak for anyone else, but we just want to know what the customer and what the community actually needs to be able to perform this sort of stuff.
Thank you, Dane. Josh, is there something you wanted to add to this?
I guess I'm skeptical about the databases, and ultimately that takes work too. And I think it would take coming to an agreement, and whether that's coming to agreement on having a common schema or a common framework, or having the proper training information for the LLM.
Mm-hmm. Yes.
The people who are down in the pipes, right, still end up needing to do the same work. And so I think my primary concern when it comes to, well, there are a bunch of databases and or a bunch of schemas, is that I can't know anything about them a priori. And so eventually I'm going to have a conversation with everyone. So the conversation I'm trying to kick off is a very early meta conversation, which is, if you're going to create a database, follow these rules, because then I can interpret them.
Yes,
right?
yes,
So
yes. No, I like that. Yeah, yeah.
Okay.
Because
Then we
you know,
agree, yeah.
I mean, we're trying to figure out how to add metadata to our data, right? And I really appreciate what Dane is saying, is that you guys want to collect all the metadata you can, but the user might not care about all that metadata, right? And what should we report? We should report the metadata that is most important for our experiment, right? Not necessarily every metadata term that we can think of. And so, that's why I think about, having, so one of the things we've been thinking about, and maybe this is a stupid way of thinking about it, is, is there one huge compiled list of terms that everybody uses, that one could then choose a definition that, through some semantic searching or some LLM would be able to pull out and identify that term that is appropriate for the definition that we need a term for. And then new terms could be put in, right? And terms could be used as they were needed.
So now we're getting into that beer conversation that I definitely wanted to have. So I'll look forward to seeing everyone in person soon. I think, so for my side, I know I need to turn over to Vanessa. I don't think there's a single list of terms. I think there is a solid list of term roots that we can define, and then we can let people extend those roots. And if we need a new root, that's fine, but that should be a more careful conversation with the community. Extending an existing root. Oh, wow, I heard myself. That should be an easy thing to do, right? That's not a long conversation. So we have some things that are big conversations and other things that should get super easy for folks like Dane and Mark to do whenever they need to, because they're doing research to come up with new hardware, right?
Thank you. So we're going to have a reply from Mark and then a question from Eric.
Just briefly, so going back to the questions about how to publish metadata and also what to provide to journals when you publish, I don't think we should forget about the fact that no matter how ideal our metadata handling develops, it's still going to be a very complex system. And empirically testing it is always a very important thing to do, I think. So if you're measuring intensity, for example, if you have something that has measurable known intensity, or if you can change just one parameter in a quantitative way, you can test your system from end to end to ensure that. And maybe there could be some, I don't know if it goes as far as standardization, but some guidelines about how to ensure that your system as a whole is not failing at some minute detail and therefore invalidating the whole thing. I think those things are also important.
All right. Thank you, Mark. Eric.
Hi, Eric Ratomero, the Jackson Laboratory. I think there's an interesting dichotomy here. I think as someone who writes software and who writes tools, I'm kind of like on the Josh side of things, where I'm interested in the process for standardization, right? Like I'm interested in the standards being extensible and versionable and easily changeable, while for the users, and defining users very broadly here, they're more, and this includes, for example, the instrument vendor companies. They're interested in the standard itself, right? They are interested in having a thing that is relatively stable they can write against. And I think there's an interesting tension here where the people actually writing the tools and actually developing new things have a different set of requirements to the people using those tools, right? And I want to know if any of you have any ideas of how to resolve this tension.
I can, so I think there can be a way of solving that tension by, for example, a clear example would be the MBOQ effort to standardize some aspects of camera metadata with the manufacturers. That would obviously not be the end all and be all. So there would be some subset. So we need a framework, that's for sure. We need a way of writing it out. But then this way of writing it out could be taken, that could become, for a certain subset, it could be like the responsibility of a group that decides that they want to standardize more like what Josh was talking about, the terms and the structure, using that framework. And then, but then there is all the very clear extension places where you can add more stuff. So Dane wants to add much more, they can put it there. But then for the users, there are a subset that they will always find those terms, and they will always, they will always be able to recognize because the terms are the same. And there has been a community that has gone through, both the needs of the manufacturer and the users to come up with that subset. So I think we can find a way of achieving both. And in fact, having this concept of extension points, it's really key to find this middle ground.
I think when we look at the hardware of a microscope, that is relatively very, very stable in the parts which you have in the microscope. Yeah, you can exchange it, you can exchange your objective, but when we look at how often it happens that you read with whatever program the simple parameters, what filter was used, how easy you can lose that. This means it's not at all standardized because this is very simple information. So I think if we would agree on, I would say, a hardware framework, that would be the first step. And then, as Dan said, you can throw in whatever you like, but if you do not agree a little bit on the naming, it's of no use, because then you have just a drawer and everybody can fill in. I would name it then garbage, because as soon as it's lost within that and it's not standardized at all, the naming, then it's of no real use, because you will not find, then you end up with the people from bioformats which have to dig all the time through this different names. And I think that has to stop, because it's also a waste of money. Yeah.
Okay, I think we have to stop.
Right. So
I know we're out of time, but I wanted to make a very quick comment maybe for the coffee break, just to Allison's comment. Could the journals require microscope benchmarking?
All right, so look, we're running out of time, but this has been a very productive session. So let's have a last round of applause for the panelists. And thank you so much, everybody, and keep the discussion going. Thank you.
Thank you.
Bye-bye.
Thank you.
Bye, all. Take care.
Thank you to our online panelists.